In the previous lesson, we talked about the transaction. A transaction is a couple value time that is scheduled on the signal. The set of transaction for a signal is the driver for that signal. In its turn, the driver is driven by the source of the signal. The source of the signal is either process that assigns value to the signal, or a connection of the signal to a port of type in, in-out, or buffer. A signal can have either a single source or multiple sources, therefore one or more drivers. In the case of more than one driver, the signal must be of a resolved type, and a resolution function must be associated with it. This function must resolve the drivers into a single transaction. It is illegal to have a multiple drivers for a signal which is not a resolved type, that is, a signal for which the bus resolution function is not defined. In order to confuse your understanding, here there are some examples of drivers and source. I hope this should clarify the concept. When we introduce the process statement, in the example, we talk about driving the output port of an entity. In the driver definition, we state that a process is a driver for the signal. In this case, the process is a driver for a signal A, and the process statement is OK, because we have a single process driver and two signal assignment in this process. In this example, the assignment on signal A seems to be the same of the previous one, but two different processes execute the task. This is an example of multiple drivers. As we state, the process is a driver for a signal. This code is illegal since the signal A is a not resolved type. In fact, integer type is not resolved, as we will see going ahead. In this case, the simulator will raise error. If A have a resolution function, the simulator will compile the code. The code syntax is correct. In layout phase, the analyzer will raise a multiple driver error. In this case, we have one driver. In this case, two drivers, because we have two processes. This example is a concurrent assignment of signal A in the statement section. Also in this case, A has a single driver. This situation is very similar to the example on the left. Also in this example, A has two drivers that are represented by the two concurrent assignments. First driver, second driver. It's very similar to this one. Let's design a four-way mux similar to the example seen in the previous lesson. In this case, the mux selector is a bit vector, that means is a bus of 2 bits instead of two different lines S0 and S1. An incorrect way to describe this mux is this one. Now read with attention the code of the architecture. Stop the video and try to answer why this is a bad mux implementation. Okay, stop the video. You are still here? Stop the video and answer the question. I hope you will find the answer. It is clear that this implementation creates 4 different drivers for output E. In this case, the simulator will raise a multiple driver error on signal E and stop compiling. Being more precise, the simulator stops because the type bit vector is a non-resolved type. Having a multiple drivers on a signal is not a syntax error. Better and canonical implementation of 4-way mux is this one. In this case, only one driver is present for signal E. In fact, the conditional assignment is only one. As a rule of thumb, in a concurrent statement, each assignment is a driver for the assigned signal. As we will see, this is not true in the sequential statement.